Zach of why blackjack is not compound independent events. Uh-oh. Where'd my giant die go?
Oh, it's right there, Mr. Hudson.
Oh, it's out. It's not normally sitting there. That's not where it
I'm
is.
sorry.
So, if I, hey, once we have our header, we are ready in blue paper. I think is there something on there? Is there example in class?
There's just right in.
Yeah. So we're looking at this, but then we're going to put it away. So this right here is what we're talking about: independent and dependent events. So I have a deck of cards, a coin, and a die. Let's talk about some situations. We're going to go small prize, medium prize. I'll give you my card. Yeah, that's a joke. Sorry. I tell you when I'm lying. Not a joke, I'm just lying. Sorry. So, Molly. You win if this flips heads. You win getting to do your homework. So, what's Molly's chance? 50%. Now, it was tails, actually, for what you care. I come over to Araya. I say, Araya, you win if I flip heads. What's her chance? 50%. Right, 1 out of 2. I come over to Mirabelle. I say, Mirabelle, you win if I flip heads. What's her chance? 50%. Now, hold on. I go to Lily, who has grown a beard. And I say, Lily, you win if we roll a 1, and I roll it. What's her chance? 1 out of 6. I come to Zach. I say, Zach, you win if you roll a 1. We roll, what's his chance? 1 out of 6. Come to Nick, same story. What's his chance? But hold on.
Oh, wait, first of all, did they win?
Wow.
I come to Meredith, and I say, Meredith, you win if you draw an ace. What's her chance? 4 out of 52, right? There are 4 aces out of 52 cards. Meredith draws, it's a 2. She keeps that card. I come to Maeve. I say, Maeve, you win if you get an ace. What's Maeve's chance? Is it the same?
Yeah, since ace hasn't been pulled out yet.
Yeah.
Oh, wait, no, isn't there a better chance because it's 4 out of 50?
Oh, yeah.
So this is the difference between independent and dependent events. I've got some people not listening, and this is where on the mastery this week, you will not be able to define for me independent versus dependent. It's not going to be end of chapter because this chapter is really big, but we're going to have a quiz. By at least
Like a mini mastery?
So, give me your eyes and your ears and whatever. Independent means it doesn't matter, right? You're independent. Your coin flip is independent of your coin flip is independent of your coin flip. Your dice roll is independent of the next dice roll is independent of the next dice roll. But if you're picking cards and you keep that card and you keep that card and you keep that card, Zach's draw is dependent. His probability depends on what has happened. If he's looking for an ace to win, and what if Araya had an ace, and Lily had an ace, and Mirabelle had an ace? He has 1 out of 49 now, right? Because there's only 49 cards left in the deck. Because we pull, now these are aces, but what if they had aces? Yeah, it'd be 1 out of 49. So guys, whatever you...
This is more than just TV.
Someone's on my Bluetooth.
I'm telling Mom.
No, I think Terry's computer might accidentally be on my Bluetooth.
Internet device.
Someone's internet connected device is hijacking my Bluetooth.
There's a hacker.
Mom, get the camera.
What? Alright, so whatever you need to write down. Now, hold on. Hold on. What if we rewind that, and instead of them keeping their cards, We put them back in the deck. Is that independent or dependent? Independent, because if we reset, if everything resets, that's independent. Nothing has changed. Dependent means one thing depends on the other. You alright? You look tired. Or bored. Am I boring this morning?
No, I'm tired.
Alright, so navigate your device, your internet connected device, to 543, and there should be an E tool. Right here. 543, student E tool. Now while people are finding E tool, here's what's up. Chris feels like life just isn't fair. Who thinks life just isn't fair? Right, so Chris has been washing the dishes a lot, and he thinks his sister's not washing them enough. So Chris proposed to Rachel that they each get 2 coins. Each day, she and Rachel will take a coin and flip their coins at the same time. If the coins match, Chris washes the dishes. If the coins don't match, then Rachel washes the dishes. So what we're comparing here is, do the coins match or do they not? So what you want to set up on your paper is just like a place to keep track of tallies. Yeah, tallies. Like we're just going to keep track. So match, no match. I want you and your partner to use that E tool. And when you click the coin, they'll flip. Flip both of them, and then put a tally wherever it belongs. So I just got a not match, right? I would click them both. I would put my tally down, then I would click them both. I just got a match. So try this out on your own.
How many should we do?
As many as you think would be a good denominator.
Should it be an even number or odd number?
Well, it depends, but evens are normally better. Whatever number you think would be a nice, do it at least 10 times, but collect a decent, I'll give you 2 minutes. Collect a good chunk of data. Make sure you're clicking both every time. Is this theoretical or experimental? Experimental, we're doing it, right? This is experimental.
Oh my god. Nice.
What the chances are?
Do what you're supposed to do. Are you sure you're clicking both of them every time?
Yes.
Interesting.
See, another one.
Oh, then yeah.
See, another one. Another one.
Do we only need to do 10?
Another one. Yes, finally.
Yeah, 10's a good stopping point. Ooh, mine are pretty even.
Yeah, it's the same chance.
Another one.
Ours are definitely not.
Another one.
Oh, I changed it.
So go ahead on your paper and write down EXP for experimental, and whatever you got. I actually got the probability of match to be 6 out of 10, and I got the probability of no match to be 4 out of 10. You got 50-50?
Wait, no. That's the first one. We did an odd.
Then draw a squiggly.
We got the same thing.
6 and 4.
Yeah.
Now, let's use random cards. This is a
Well,
good idea.
technically we did, but we got 11.
Technically you did. For those of you who yell at me for shuffling, I'm not shuffling. Because we haven't made it. Well, we haven't made it all the way through since we came back. Nick, does the second coin flip, or is the second coin flip impacted by the first? Nick shrugged and shook his head in this weird, why are you even asking me? No, the second coin is not impacted by the first. So, hold on, when you think about each coin, draw this on your paper. Like a square. You think what?
You got 15 and 5
Olivia's not here. Witness protection. Molly, what is our chance of flipping a heads on coin 1? Yeah, thank you for using the fraction. I know you were tempted to use the percent, but the fraction's better. So heads is 1/2 and tails is 1/2 because it's a fair quote-unquote coin. Unless it's rigged. Maeve, what about coin 2? What's its chances?
Pass.
Is coin 2 different than coin 1?
No.
So we know coin 1's chances. If coin 1's chances are 1/2 and 1/2, what would coins 2, if it's a different coin, different flip? It's just 1/2 and 1/2, right?
Come on, Hudson. Or false information.
Yeah, that's why I didn't let it happen. You can always say pass. That doesn't mean I'm necessarily going to move on. So, Meredith, if we think about the fact that there's a 1/2 chance on coin 1 of getting heads and a 1/2 chance on coin 2 of getting heads, what do you think the chances of getting a matching heads and heads? Do you think that's a 1/2 chance? Let's think about the possible outcomes, right? Coin 1 heads, coin 2 heads. Coin 1 heads, coin 2 tails. Coin 1 tails, coin 2 heads. And coin 1 tails, coin 2 tails. So that's, actually this is heads, heads. Right? This is tails, heads. This is heads, tails. And this is tails, tails. Coin 1 heads, coin 2 heads. Right? This is tails, heads. This is heads, tails. This is tails, tails. Lydia, do you have a guess of what the probability of heads, heads might be? Toby?
Yes, Lord?
Here's your chance.
Okay. What's the chance of heads is?
Yeah.
Wow. You see, in that box, heads is only in there 1 of the 4 times. So I'm going to guess 1/4.
Your guess is correct. Each of these has a probability of 1/4. No, wait, so the game was they match or they don't match. Okay, so everyone close your Chromebooks because we don't need them anymore. We just did that to collect data. We got some people still playing, and they're off topic, and I'm worried that their tables aren't filled in. Is your table filled in? I'm not staring at you for fun, Morgan. Is your table filled in? Okay, because I can tell you guys are still playing on your Chromebook. So, if we have match and not match, match is here and here. Well, if we have 1/4 and 1/4, what's 1/4 and 1/4? 2/4. What if we have the not match, you can't really see that, and the not match? That's a 1/2 also. Is this game fair? Yeah. Because remember, what did we say fair defines as? What's the definition of fair? Yeah, equal chance of winning. little bit of shorthand here. Sorry, equal chance at winning. So this is what's on your blue paper. Then we're going to put it away. Coin 1 and coin 2, were they independent or dependent? Independent. They did not impact each other. Right? Dependent impacts the other. So this is on your paper. Whatever you need to underline or highlight or whatever before we move on, then put your blue paper away. Should not see any more blue papers on desks. On your graph paper, all I need you to write is win, lose, tie. Now you will need to be in pairs for this, except we have an odd number today, so Callie, I can come play against you if you want. What we're going to do is play... We are going to play rock, paper, scissors. I was trying to decide how many rounds. Let's try to play... I'll let you decide whether you play 9 rounds or 10 rounds. So let's take a few minutes against a partner. Now hold up. Hey. This is difficult because if Zach wins, he's going to put a tally on win, and Nick is going to put a tally on lose, right? You're not writing down the same thing, right? If you tie, you're both putting a tally on tie. Rock, paper, scissors, like you both throw the same thing. Rock, paper, scissors officially is to be played by, I don't want any rock, paper, scissors disputes in here, by calling out together rock, paper, scissors while moving your hand in an up-down fashion. Then on the word of shoot, you will throw one definitive, not one definitive, either scissors by the show of 2 fingers, also known as a peace sign, paper by a show of a flat hand, or rock by the whole fist flat. There will be no discrepancy on who did what. Any questions? Hold up. This is where the fights happen. This is not a rock. It is a, oh wait, crap, no scissors. This is a rock, okay? Do not, because this, people cheat, and they're like, rock, paper, scissors, shoe, like, they wow.
Rock, paper, scissors, shoe.
Sure, but don't then change it, like, just be cool. Don't cheat, okay? Go, play. No questions. Okay, ready? Rock, paper, scissors, shoot. Don't lose. Do I have to tell you what the spot? Rock, paper, scissors, shoot. Hey, keep track of ties. Please keep track of ties. Rock, paper, scissors, shoot. Rock, paper, scissors, shoot.
Let's keep going.
So now, hey, once you do your 10, yeah.
We did 14.
Hey, write down your data. According to Callie and I, well, I'm going to steal Callie's data because she kept track of it. You won 4 times, or what was it? It was 4 ties, but what else was it? So her probability to win was 2 out of 10. Her probability to lose was 4 out of 10. Now she had a hard competitor because I'm good at anticipating.
See?
Yours may not be the same.
I told you.
All right.
Can I do 14?
By accident.
I mean, if you want that to be your denominator, I would almost do one more and just make the denominator 15. But. No, wait.
Oh, wait.
I want opinions. Nick, what do you think?
When there's like a cheater or a boothead,
A what? How do you cheat at rock, paper, scissors?
right.
Oh, yeah.
And then you put your answer, but then you go like,
Oh, yeah, you like wait till they
yeah.
So wait. So
Yeah, you could wait.
hold on. We're gonna talk one person at a time. Like classes are supposed to work. I know mine doesn't often work like that. But. So wait, you said the cheater would do what now?
Like do like slow down with slow motion, and then like I would be, but then you go, right.
So what you're saying is the cheater, gentlemen, the cheater makes his throw after the other person?
Yeah, and then it says it was at the right time.
So wait, so that
I'll give you
means,
an example.
so hold on, Meredith. So that means person 2's throw, is it independent or dependent?
Person two? It
If,
depends on the
if person 2's a cheater, like Nick's saying,
cheater.
and they waited to see person 1's throw,
Theirs would be dependent.
theirs is dependent. So what if I change the rules of rock, paper, scissors? There was a 1 second delay between throws. Would that be fair?
No.
No, not at all.
Well, yeah, if you made it for both people, then they would both wait a second and then
Well, would that be a very fun game?
No.
No, not that, like, there's a person 1 and a person 2, and person 2 throws 1 second after person 1.
Oh, yeah.
The person 2 is always going to win, right? So, dependent here kind of makes this not fair. Savannah?
I tried this on Bella. I know, like, one guy went around and played, like, 100 games of rock, paper, scissors.
Yeah.
So, if you ask someone, like, what color their shirt is before you play rock, paper, scissors, it confuses them if they're wondering what you're doing. So, by default, they usually go to rock. That's like the most popular motion. So, you can kind of predict what they're going to do or not.
Interesting. I like what you just said, though. You can predict what they're gonna do. So wait, can we predict how a coin is gonna land?
I mean,
Yeah. I mean,
Not
you can,
really.
But like, yeah, no.
Lily, hey, bring it back.
I'm just observant, and they're different, and yeah.
What?
You used to have both of the two computers that went up and down, but now you only have one that goes up and down.
I know, because the technology got all goofed up and it was arguing with each other, essentially. So, it does not matter. What she noticed does not matter. So, when we talk about rock, paper, scissors, is it fair?
I mean, if there's no cheater, then no.
What? Hold on. Let's say you throw. Hey guys, I have like 5 side conversations. Like, not exaggerating. I have 5 different people talking. If you throw rock, what happens if they throw rock? You tie. What happens if they throw paper? You lose. What happens if they throw rock? Or scissors? You win. So there's lose, tie, win. On each option that I throw. And assuming we throw it the exact same time, the only thing that would make this not fair is being able to predict the other person. So if you are unpredictable, is it fair? Yeah, I mean, we could argue, like, yeah, there's no, like, it's a 1/3, 1/3, 1/3, right? Like, one of the 3 things my opponent throws beats me. One of the 3 things my opponent throws, I beat them. And one of the 3 things they throw, we tie. So do we each have the same chance of winning? Yeah, unless you know something I don't know. So remember, fair just means equal chance of winning. So, in that case, if 2 people play 12 times, let's say they ignore my advice, and they go beyond 10. So, Aurea, or Molly, I guess either of you can answer this. If you played 12 times, what would you expect for how many times player A would win? Doesn't matter. You have player A versus player B, not based off what you did, but what would we expect? Like, you're going to play a new round 12 times. How many times do you expect player A to win versus how many times do you think player B? And we'll say they're equally matched. Actually not. Because remember, they're not flipping a coin, they're playing rock, paper, scissors.
Oh, would it be 4-12?
Why?
Because there's like 3 different options of you could tie to a winner, you could lose.
Yeah. We would expect right, but our expectation. It should be though. And if you guys are strangers and you're equally matched, you should win 1/3 of the time, lose 1/3 of the time, tie 1/3 of the time. Hey, give me your eyes. I got some people writing and I'm not quite sure what you're writing. When we talk about rock, paper, scissors, has 3 outcomes. Win, lose, tie. We're saying your chance of winning is 1/3, your chance of tying is 1/3, your chance of losing is 1/3. Not when we did the experiment, because we know, like what Lily's saying, the experiment comes out different. When we actually do it, it comes out different. But what we expect would go with the theoretical probability, right? Our 1/3, 1/3, 1/3, what we think, because expect is what we think, right? It's not what did happen. It doesn't say do it. Well, it does down here. But up here, it doesn't say do it and collect the results. It just says what do you expect. So now that you know the probability is 1/3, 1/3, 1/3, play 12 more times. Keep track of what happens. Apparently, according to math, you should win 4 times, lose 4 times, and tie 4 times. Okay, yeah.
Yeah, I'm right.
If you don't want to play rock, paper, scissors, don't. I can't make you.
I need to go
Okay.
You think you're going to do better this time? You're in my head now?
One.
Alright.
Rock,
paper, scissors, shoot.
Rock, paper,
scissors, shoot. I got it. Rock, paper, scissors, shoot.
No, it's not.
And what color is your shirt?
Oh my God, no! Why?
Oh, once you have 12, just stop playing.
Theoretical. We tied more than regular. I lost 4 times. He won. And we tied.
4 times. And you played more than 12.
No.
Did you say 4, 4, 7?
4 plus 7. And then I lost 1.
Oh, 1.
1 plus 7 plus 4 plus
Bum, ba, bum, bum, bum.
Why?
That was a bum, ba, bum, bum. You guys don't even know what show that was from, probably.
Why?
Wait, Rugrats. What is it?
You know what I couldn't? Like if I was like an actuarius working for Chase Bank, but because I'm a teacher, I can. So that's why. All right.
What is the show?
Who has opinions? I'm gonna leave that as your task. I had people yelling at me that math is wrong, or like things like that. Sam. Yes. About this. About rock, paper, scissors, the math. So what did you guys find out?
I tried to rid Bella again, but
Since you told the whole class and you asked somebody.
she ignored me and then tried to do it to me, but I ignored her. So we kept playing, and
If you don't have an ending to your story, just say, and then I found $5.
And then
Kobe?
I found
Rome?
My
A person or a place?
My opinion is that Eric should have kept going like this every time.
Oh, wait, that was you!
No, it wasn't.
Yes.
And then I found $5.
And then I found $5. Lily?
actually, math is incorrect
Now wait, what do you mean by that?
according to science.
Okay, what do you mean by that?
I was
Hey, bring it back. We got one more thing to do. Bring it back.
math is correct.
And?
No.
So what you're saying is the experimental results did not match what we anticipated. Does that mean it's wrong?
Yes.
No. That just means it's different. Hey, give me eyes. I only have like 3 sets of eyes on me, and those are from like 4 different people. In the time of you guys doing science fair, I need you to hear me when we say results that you collect that don't match what you thought would happen aren't wrong. They're just experimental results. So, who remembers me talking last week about the law of large numbers? If you played rock, paper, scissors 1,000,000 times against, against 1,000,000 different people, not the same person over and over again, that you can kind of start to anticipate, your results should be pretty darn close to a third. Now, let's switch gears. We got to answer a few more questions before we get out of here. These sequences of events, this and then the that, what we want to talk about is it independent or dependent and why? I need you to take a minute without talking, read these, be ready to answer them, and then I'm going to random card to get your feedback about what you think. So remember, independent, they do not impact each other. Dependent does. The second thing is impacted by the first thing. So take a minute. Read these. cube. Normal die. Not like when I lied to you and I'm like, it's not my fault you're not used to a D30 being in the bag. Morgan, what do you think about A? Hey, please stop talking if you're not the person I called from the card, Morgan. I can't see you, I can't hear you. Why independent? Yeah, it's like, how could a second coin flip be impacted by the first? That would be weird. Eric, what about B, choosing a jack from a standard deck, not putting it back, and then choosing a king?
I think that might be independent.
Okay, tell me why. Hey, stop packing up, because you're not listening if you're packing up.
Because you didn't put it back in the bag and then you chose the king stuff instead.
So when we don't put it back, does that impact draw number 2?
It does, because then
So wait, is that independent or dependent? This one is dependent because they do not put it back. They do not put it back. Sarah, what do you think about picking a blue marble from a bag, putting it back, and then picking another blue marble? Independent because we put it back. When we put it back, we did not change anything. And then Callie, what about rolling a 6 on a number cube 3 times in a row? Yeah, because roll number 2 is not impacted by roll number 1. Independent. Please do your homework. I'll see you tomorrow. Put your Chromebook back, please. You are out on time and you don't have far to go. So please put your Chromebook back. That's not far. You have to go all. You know, when I was in 7th grade, the school I went to is 4 floors tall and big.
So did my Nana.
So did your Nana?
Yeah.
She went to Coshocton too?
No, she just went to a really tall